Everyone, and welcome back. So let's try some problem on force today. So first off, the first part of any problem is reading it. So a resupply ship is being designed to use ion engines like this that run continuously, providing a small but constant acceleration, of 0.6 meters per second squared. Okay. The resupply ship has a mass of 30,000 kilograms. What is the thrust, the force, provided by the engines in units of pound force? Now, the first part of most problems is to get everything in metric. Luckily, kilograms in meters per second squared is already metric. So from that, we can calculate the force in newtons. Because force equals mass times acceleration. That's going to be equal to 30,000 times 0.06 kilograms and meters per second squared. So that will give me newtons. Okay. So this should be, let's do our math here. 1, 2 back, and multiply that by 6, giving me 1,800 newtons. Okay, with 1,800 newtons, we now need to convert it to pound force. There's a very simple conversion for this. 1 Newton is 0.225 pound force. That's in your book. If we multiply these together, what we should get, if I've done my math right, which is not always the case, we will get 405 pound force. So it's that simple. You convert everything to metric. It was already there for us. Use our force equals mass times acceleration equation, and then you convert to what you need. And now I'm going to go ahead and show you that the answer is right. Hopefully it is. And it will pop out. It's going to be kind of a monstrosity because it gets covered up by a bunch of stuff. But yes, 405 pound force. Woo! Math! Okay, let's do another one. Just to give you some more experience doing this. So, for this one, the engine on a spacecraft nearing Mars can provide a thrust of 15,000 newtons. This is amazing. I just gave you the answer. Not supposed to see that. 15,000 newtons. If the spacecraft can accelerate at a rate of 22 meters per second squared, and that was acceleration, what is the mass of the spacecraft in pound mass? Okay, so we want mass here, and we want it in pound mass. Don't forget the unit, and don't forget what you're solving for. Both are important. So force equals mass times acceleration. I want to solve for mass, so I divide both sides by acceleration. And that gives me that mass is equal to force divided by acceleration. Now, since both of these are in the metric units, we'll pop out kilograms. That's okay, we can convert that at the end. So mass is equal to 15,000 divided by 22, which will come out to be roughly 7,500-ish. Yeah, I'll pull my calculator. That's how it goes. Okay. 15500 divided by 22 equals 681. That's why I should not do mental math in my head. And that's why we check these things. Okay, that's 681. There's more other decimal places, but we're going to round this off now. Okay, and now I need to convert that to pound mass. So 1 kilogram is 2.205 pound mass. Now if I multiply those together, once again use my handy dandy calculator, I get 681 times 2.205. This will be 1501, 1502, somewhere around there. Okay, so the answer will be 1,502 pound mass. I think I'm probably going to be off a little bit by rounding errors, and that's okay. So if I hit the button, 1503. Okay, 1 pound mass. Give me a break there, everybody. I tried my best. I lost a couple decimal places. So as you can see, just getting rid of that, we solve for what we want and get it in terms of that. We plug everything in metric, which will pop out some metric unit, and then we convert that metric unit to what we want. That's usually the best setup. Sometimes there's shortcuts where you don't have to convert everything to metric. Sometimes it's better not to. But as a rule of thumb, if you don't see that shortcut from the very beginning, use this method where you go to metric first and then go from there. Well, I hope this helped you, and I'll see all of you next time. Bye-bye.